Thank you for the introduction and thanks for the invitation. I'll try to keep things interesting. See how we go. And I'm going to talk about quantifying uncertainty with what we call structured expert judgment. Expert judgment has a lot of names: expert opinion, expert knowledge elicitation. Some like it, some hate it. We tend to do it in a structured way and insist on that. So that's what I'm going to be talking about in the context of quantifying uncertainty rather than taking it out from the modeling process. So you've already introduced me, thank you very much. But this is the one to remind you that I'm a very technical person. So if I get anything wrong in terms of human behavior, cognitive biases, everything that I'm going to talk about, and you're much more experts than I am in that area, please let me know. I am happy to be corrected, criticized, and I'm happy to learn from you. So my background is very technical. I did theoretical maths back in Romania, and until I started teaching it, and all my students were asking me, yeah, great, theorems and proofs, what do we do with them? How do we apply them? No one taught us that. So I just went over to the Netherlands where they taught me how to be an applied mathematician in the area of probabilistic modeling and risk analysis and environmental modeling. And that's where pretty much the way I look at the world in general and at my work works. Everything is just a probabilistic model, if you ask me. Then I came over to the University of Melbourne to work with Mark Bergman on structured expert judgment. So while in the Netherlands, and you'll see at the Technical University of Delft, there's actually one person who started and did lots of expert judgment experiments and actually coined the term structured in terms of structured expert judgment. We've organized lots of networking events, and we had meetings with people from all over the world who do expert judgment in slightly different ways. Mark Bergman was one of them, came over to Delft, and that's how we started working together. And then I came to Delft to work with Mark and Fiona Fiedler, Victoria Hemming, and Bonnie Wintle. Some of these people you probably know. In this particular sort of space, Mike Berman at the time was the director of the Center of Excellence for Biosecurity Risk Analysis. So most of the applications we worked in were based on biosecurity modeling and decision making under uncertainty. So SEBRA we started as a Center of Excellence, but it's been around for 20 years. So not necessarily Center of Excellence like. It's a fixture of the School of Biosciences, University of Melbourne. It's a venture that is co-funded by the Australian government, by DAFF, Department of Agriculture, Fishery and Forestry, and the Ministry for Primary Industries in New Zealand, with some co-funding from the University of Melbourne. And what we basically do is we take whatever stakeholders, decision makers in the government want to model or have a question about in terms of the biosecurity space, on the whole continuum, what happens pre-border, what sort of horizon scanning they do for pests and pathogens and threats that could come to Australia, or at the border, what sort of measures they should have. All those cute detected dogs, they meet you at the airport and sniff your luggage, all the inspections, or post-border, where do you invest in surveillance to make sure that those pests and pathogens are not here yet. So the whole spectrum of problems, they're all framed in terms of decision-making under uncertainty and kind of mitigating risks and understanding impacts and resource allocation. Come to us with problems, we formulate them, if it's me, in terms of a probabilistic model, and then go over from there. So the process that it's usually at the basis of how we deal with problems starts with a decision maker coming to us. And I have it in the first box as a conceptual draft model. It's usually a question that we start working with them to formulate it and put it in a sort of mind map that we could work with and transform it into a formal model. Then after that, after we have a bit of a back and forth to understand that we're really reformulating their question in the way that they need it, we can actually model it. We go away and see if we can have the tools to model it. What is the more appropriate tool to do that? What sort of model would have the assumptions that are not absolutely ridiculous? And once we set on that, we finalize the models, and almost every time there's not enough data to parameterize the models that we're working with. Most of the time is things that will happen in the future. So we could stop and say everything that we have, the data that we have is perfectly representative for what we're trying to model, but we know that's not the case. So the data gaps that we will always identify will have to be parameterized with what we call structured expert judgment. So that's the bit where that's when we start talking about structured expert judgment in terms of quantifying uncertainty in the same space where we talk about what's the data that I need to parameterize my model. So this is the context that we have for the expert judgment. And that validation box sits there alone, but it's just because I don't know how to do beautiful diagrams. That's pretty much in all of the steps of this process. You would have validation, verification steps, and changing and refining your models. So like I said, expert judgment is used for a very long time. It's been used, and there's an interview with Roger Cook from the Technical University of Delft saying that most of the scientists use it, but they don't want to admit they do it because they don't do it properly. And that's, experts can be wrong, and they can be massively wrong and with lots of consequences, especially if you do an informal on unstructured exercise. Does anyone know what this is? This is Italy. This is the L'Aquila earthquake. And this is the scientist who, before he entered the meeting to actually talk about what's the probability of an earthquake the next day, he came out on TV and said, just go home, have a glass of wine. And he and the group of experts were in jail for that. So there's a lot of skepticism about expert judgment in the earthquake and volcanology space in Italy since then. Everyone's saying a lot.
Kind of like that, right? It's sort of absolutely out the
Yeah, but
processes. Why would anyone come out and say that certainly?
I guess he paid for that. He will never do it again. And yeah, so about 10 years ago, Mark and Bill Sutherland wrote a paper that was very successful about how to use experts wisely. And this is pretty much what we mean by structured. That's what puts the structured in front of the structured expert judgment. Use them wisely. And the main two things I think that came out of that piece and from our experiences, you don't ask experts for preferences or values or utilities because you're going to get what you deserve. Stick with the facts. Ask them about things that you, in principle, if you would have the resources, you would be able to measure. Ask them what you would, in principle, be able to ask nature. So stick with asking about estimates of facts, predictions of events, outcomes, and so on and so forth, not preferences or risk appetites. So before we go further, a bit of history. Like I said, expert judgment has been around for ages. It started with the Rand Corporation that did all sorts of predictions in the 50s using the Delphi method, which I assume everyone is familiar with. And it was mostly quantitative and rationales, qualitative reasons for those numbers. Then the nominal group techniques improved the small group decisions. So they figure that it's good if people are in the room and talk to one another, that will improve a decision-making process, mostly in a qualitative way. The estimate talk estimate is meant to refine the numerical estimates. So it's a bit like Delphi, where they first do independent thinking, they estimate, they give you an estimate, a prediction of something, but then they come together as a group and talk about potentially anonymized numbers that they gave and the reasoning. So they make sure that there's no ambiguities, everyone understood the questions in the same way, the context is the same, and so on and so forth. And then they go away and estimate again so they can change their mind if they misunderstood something. So that was already around in the 70s and 80s. And then around the end of 80s and beginning of 90s, then, the commissions and the European Commission started admitting that expert judgment is something that we actually really need. And it's useful. And if you do it properly, it will add to the value of their analysis. So I think one of the adoptions that they took was this Cook's classical model, which is the same Cook that I've mentioned earlier with the interview and the guy from the Technical University of Delft in the Netherlands. So he put together the classical model for expert judgment, and it was the first time that someone used the word structured, and he gives a working definition, not necessarily a theorem and a proof for it, but it gives a working definition of what a structured protocol is. And since then, there's other methodologies. The Sheffield framework is another one, and I'll touch on that later in the talk. So these are the ones that pretty much the structured methods. That's why the little thing in the corner there is to remind you that it was in the same box as structured expert judgment and data parameterization. Basically, the working definition of a structured protocol is just thinking about collecting expert data just like any other field data. Make sure you have the same sort of rigorous process to collect expert knowledge than you have when you collect field data. And since then, there's been a lot of others working on these protocols and trying to get the best elements of what we know works, what we know makes the estimation of the experts better, and we'll get to what better means as well. And yeah, so that's the protocol that we've been using quite a bit. Yep.
Just a quick question.
Yep.
I'm familiar with the old AHP, the analytical hierarchical process. Is that somewhere on the Cook's thing, or is it before? Does that belong here or no?
I don't think so. I don't know. I may not be familiar with
Okay.
what. Yeah. So if you tell me what it is, I will tell you if it's in one of these.
The analytical hierarchical process. It's
Where you go and ask experts
it's
for.
in geospatial.
But you work with experts to build the models. Yeah. For the qualitative part of the model or for the parameters?
Suitability.
Yeah. Well, I'll show you what the
Yeah,
Cook
makes
model
sense.
does, and then you'll tell me if it's within that space. So there's, like I said, there's no definition of a structured protocol. There's a few guidelines that we all follow, and we all agree that they would be necessary conditions for a structured expert judgment for a protocol to be called itself structured. They may not be sufficient, but these are the ones that we know work. So first of all, ask questions. If it's in the area of quantifying uncertainty or asking numbers, asking numerical estimates, ask things with a clear operational definition. If you're not able to measure it, then it's very hard for the experts to answer the question in exactly the same way. So don't leave it vague, because it's going to introduce a lot more uncertainty than you're maybe hoping for. The follow, like the next 2, 3, and 4 dot points is just use a scientific method. It's nothing more special than that. The fourth point there, allow empirical control. That's one that is debatable. Some like it, some hate it. Some people in the structured expert judgment community, I mean, think there's no way you could introduce empirical control because you're asking experts about something that no one knows. So how would you be able to validate or control for that? The next two are things that you know much more about than me, is basically acknowledging that you're working with people and you're asking them to do a very complicated task. You're putting a lot of pressure on them, thinking under uncertainty, it's extremely hard, so they're going to use all sorts of tricks and heuristics, and that will lead to biases. And the last one is, because we pretty much all agree in the community that it's much better to go to a group of experts than to just ask Bob from upstairs, then you will have several answers for the same question. So you will have to have a way to aggregate that and say, this is the group answer. A group is much better than the best regarded expert. So initially that was a group is much better than the best expert, but because you don't know what the best expert means, then it's the best regarded, because very often you would go to people and they say, oh, you should ask this person, they're the expert. And unfortunately, I have that in rooms with experts when they would go, I can't answer that question, but he can because he's the expert. She's like, no one's is the expert. There is a best regarded expert, and that's a completely different topic. We did experiments with how people see themselves, how experts they think they are, and then measured how well they perform on these questions that we knew the answers. And there was no correlation whatsoever between how good they think they are and how good they actually are. But we all know that if we go to a group of experts, what we strive for is diversity of opinion. We want diverse voices in the room. And again, we use all sorts of proxies for that in terms of experience, age, background, worldview, whatever we can. It's important to let them think independently before they enter the room and just listen to everyone else and go what she says. Draw on their own local knowledge so they can engage things like extrapolation to other sort of domains, but actually anchor in what they know for their own space. And then at the end, when the aggregation, I think most of us agree that you have to aggregate their judgments to go with one parameter to put in your model and to run that model and show the decision maker whatever results they need to see. There's one group of Grange and Morgan who thinks you shouldn't aggregate at all. You should just take each and every estimates that you have, run them through your model, present your decision maker with all those options, and they can do whatever they want. This is not the most practical thing I think you can do. And very often you already stress your decision making with presenting uncertainty, let alone giving it a few options, all of them with uncertainty. It's a very hard thing to actually work with. So we go for aggregation. We think aggregation is a good thing, and you can do it in two ways. You can do it mathematically, or you can do it behaviorally. So that's one of the points where this different groups of practitioners in expert judgment have different opinions. There's the school of thought who thinks maths is better than behavior. Yeah.
That's a quick question. So
Sure.
like, is there any consideration of kind of like the independence of the sampling of those experts? So like, if they're all
Yeah.
from the same department or even the same city, it might share biases
Yeah.
and all that sort of
Yeah.
stuff.
So that's one of the arguments of the behavioral people who you put them in a room and they talk about what they initially said until they come to a consensus, because they're going to influence one another, because you're going to have correlations. There are very few studies that actually looked at, does it matter? Yes, you are inducing correlation. Simply by asking the same question, you're inducing correlation. They're all answering the same.
Or
But then
even just, oh, sorry.
then they talk about one another. They influence one in the discussion sometimes, so that you're inducing even more correlation. But what we looked at is, does the performance improve anyway, even with that, taking that correlation into account? And there are mathematical models which actually model it with a correlation matrix between the experts and try to account for that. There is correlation. It doesn't seem to affect the fact that after that discussion, a certain aggregation would give you a better performance. You wanted to say something else?
Oh, we can talk about that.
Okay.
Yeah.
But yeah, no, that's a good point. There is correlation between them, absolutely. And you can measure it conditional on, if you would know the truth, you would mathematically be able to measure it. So going back to the fact that we're asking them to do something very hard, then we know there's going to be all sorts of tricks that they're going to use in their logic and in their mental models. There's a certain way in which most of us agree we should ask the questions. In a way to guard against biases. We don't know if we're doing it. We're hoping we're doing it. We have very few experiments that prove that it actually works a little bit. And to do that, and we're doing that because we have two lots of biases, right? We have the individual cognitive biases, and then we have the group biases if we decide to bring people together and talk about these things. And I know there's lots and lots of them, and we may or may not be able to identify them, but what we identify very, very often are these three guys. So the availability is always there. It's easier to you give more weight to the things that it's easier to recall, and everyone does that whether they like it or not. Most of this would be mitigated through the group discussion and through the reasoning sharing and everything, because people will ask you about your availability bias, and the availability biases will come together and just increase that knowledge pool that everyone shares. The anchoring, again, it's very easy to just, when you give numerical estimates, if you throw a number into the question, we know for sure that they will gravitate towards that number. So we tend to avoid any numbers within questions, so that doesn't happen. And we actually have a way of looking at overconfidence in this context because of that anchoring thing. We're asking them to quantify their own uncertainty. So we don't ask for 1 point estimate, but we ask them for bounds as well. And when those bounds are very close together, and we do observe the real value, then you can see if their intervals were really tiny and just missed that true value, then that's a sign of overconfidence. That's how we think of overconfidence. Group biases, we've all been in group discussions. We were all dominated by a certain either charismatic or very annoying personality and very loud voice. We know exactly what this is about. I bring all my experts together. This happens all the time. So I think we do the best, the facilitators in elicitations do the best to just draw everyone out and make sure everyone speaks their mind, and you can ask someone politely to just enough. Can you now let other people speak? We sometimes can do it, we sometimes can't. What helps me in most of my elicitation is that I'm completely independent. I do this from the perspective of the person who knows the aggregations and who knows the math behind that, but I don't know their space. So I don't really care who's the expert. So I can very easily tell them to shut up. That helps. And being Romanian, I guess, helps. That's what. So a few resources that talk about different methods of how to ask the questions, what sort of questions you can ask, how to aggregate are highlighted in these books. The Experts in Uncertainty is Roger's cookbook from the 1990s, and the Sheffield method that I said is mostly behavioral aggregation is this one here. Mike Bergman's book is a really good read. These guys are a bit technical. They're both mathematicians and statisticians, so it would be a lot of technicality in there. Mark's book is really nicely written, and it has lots of stories and examples. This is Granger Morgan, the person whose group suggests we shouldn't aggregate and just present all the options to everyone. And those last two are just a collection. They're edited books. They're a collection of what's been happening in the space in terms of application and theory. So going back to phrasing the question, we basically ask the same question 3 times. So this is one example, biosecurity, unsurprisingly related. One example of a question that I used to train my experts in the biosecurity space. Just this one here is the question. So it's like, how many times will something happen over the next 10 years? That's what we're worrying about. The one above here is the context for the question. And that can be that big, or it can be a couple of pages that they have in a background document that they receive together with the questions. But what I'm interested in is how many times will viable so in this was a question for New Zealand. They are worried that they will get Queensland fruit flies. They don't have it. It comes through produce or passengers bringing in infested fruit, or through their imports. And they're interested to know what would be that entry rate in the next 10 years. So we ask them this question, and we start with the lower bound. We always ask, think of all potential reasons that this value is small. And then, so we're trying to get to that sort of counterfactual thinking. In what potential world this will be small. There's variability in over the 10 years because years are different. So like natural variability will make those bounds be different, but there's also their own uncertainty. They don't know all the factors. They have to integrate everything in, which makes some of the statisticians' head explodes because we're mixing in epistemic uncertainty and variability in the same sort of bounds. But it's possible and it's doable, and we can separate it afterwards if we need to. So we go for the lower bound first, which mathematically I would just model as a 5th percentile of a distribution. I don't have to. It can be the 10th percentile. It can be anything else. But we found that people can think in terms of 1 in 20 chance. The number of times I've trained my experts and told them that this is not a physical bound versus the number of times I got 0 for this question is very impressive. So if you have any tricks to let me know how to make people read the instructions, ask questions if they don't understand, read the ones in capital, I'm very open to suggestions. So this is not, it's not meant to be the absolute minimum. It's meant to be a lower bound. And then we move them to the other space. Now, just like in terms of best case scenario, worst case scenario sort of thinking, think of all possible reasons. This is large. And then we ask the question again for the median. Put everything in balance. And because I'm modeling that as a median, I'm asking them to think as an even chance for the real value to be below or above. Again, we could ask for an expected value, we could ask for a mode, we could ask for something else. This seems to work well. And then that's what they give us in the end. It's just a point estimate and the two bounds. So what we're trying to do with that is to avoid anchoring on the best estimate, because when we do that, when we start with the best estimate rather than the bounds, they tend to go best estimate plus minus very small interval around it. So we get intervals like this, and that's the overconfidence I'm talking about. Very often those intervals are much smaller.
Is there any chance that like starting with the lower bound always kind of almost anchors them to underestimate things?
We didn't see that.
Yeah.
We didn't see that, and we sometimes alternate. There's no, when we alternate is when we're trying to do best case first, worst case second, or the other way around. Very often you have to switch bounds because sometimes things are increasing or decreasing. It doesn't seem to, but again, there were no systematic experiments to actually check for this.
I guess, is there any reason why you wouldn't just like in general always just randomly or like
I don't
balance
think
the
so.
line?
Or maybe only the cognitive load that would be for them to jump
Right.
from one to another.
Right.
So there's that we tend to keep consistency in terms of best case, worst case.
Or between people that.
We've never tried that. We can give it a go. Yes, so that's why we're asking the questions in this way. So we end up with the same, like I said, the same question having very different answers. And in terms of aggregation, the two schools of thought that I talked about earlier, so you could go for behavior aggregation or mathematical aggregation. So the Sheffield elicitation framework, which has a software called Shelf, does behavioral aggregation. So they both do the same thing. We want a diverse group of experts, ask the questions in the way I showed you, get intervals for everyone. What Shelf does is it fits nice parametric distributions, because whoever worked with the Sheffield methodology thought people don't think in just this, but they think in nice smooth curves. So that's what they would like to see. Now that's debatable. So they start the discussion with anonymized curves like that, and then they start discussing, oh, should these numbers, is there so much uncertainty here? Should the best estimate be here or there? So they just start the conversation until they reach consensus. And at the end of the discussion, you get one single curve, which is the group's estimated distribution. That's that. The mathematical aggregation, starts the same, get a diverse group of people, make them think independently, give you the estimates, and then take all those things in the classical Cook and Delft protocol. They're all the same, but they just have different names because people call them differently. I guess what Roger called it the classical model. People said it's just Roger's Cook method. I need to stay there, right? Because that's the microphone, or I don't need. Yeah. And then Delft, because he's from Delft. So that so Roger doesn't think people think in nice smooth curves. So he creates these sort of blocky distributions, because the reason for that, so it's the same thing. Those lines there can create these ones here, or you can fit those ones here. It doesn't matter. The reason to go for these ones is because that sort of representation doesn't add any extra assumption. It doesn't, it complies with exactly the numbers that they give you, and that's what you're going to get. And then at the end of the process, it takes just an average of those distributions. Now, if you give them equal weights, if you think they're all as good as one another, that's what you get at the end, just a linear combination with equal weights. What Roger does differently is he introduced the idea of seed questions, which is that empirical validation sort of thing that some other people, like this ones here, don't think it's possible. So you have a set of questions that you don't know the answers for, you need to parameterize for your model, but you also have an extra set of questions for which the answers will become available very soon, like experiments that are just happening now, and you will have the true answers. Those form what's called the seed questions or calibration questions. Now, based on that, you can calculate what sort of quality the answers of your experts have. And that is in terms of how calibrated they are, which is how often do they capture the true value within those intervals that they give you. If they capture it consistently, then you say it's a calibrated expert, and how informative they are, which means just how far apart those bounds are. So this is an example of an uninformative expert who captured the realization, because if you spread your bounds wide enough, you will capture whatever realization you need to capture, but it's not very informative. And this is on one question. That should be on a long-term sort of thing. On 10 questions, this is always the behavior, captures the realization. It doesn't have very wide bounds. This is an expert who's fairly confident, but they miss the realization. So we don't want that. We want this. Now, you can measure that for each expert, have a score per expert, have a weight that is proportional with that score, and do the linear combination with weights based on performance. So that is the performance-based mathematical aggregation that you can use using seed variables. The IDEA protocol that I said was being used at the University of Melbourne quite a bit. It started with Mark Bergman and a team of researchers working on that a long time ago and looking at what are the good properties that all these other protocols have and collecting those within a different protocol. So the independent thinking, it's a clear good thing. It's good for people to think on their own before they hear what their peers have to say. The discussion is absolutely fantastic to just get rid of the ambiguity, make sure they're all answering the same question, they're conditioning on the same factors, they understand the question in the same way, and they cross-check their other reasoning. They actually question what the reasoning was. And then based on that, be able to change your mind. That's also, it was found to be very useful. What we didn't think was very useful was the striving for consensus thing. So we ditched that and we're doing mathematical aggregation in this investigate, discuss, estimate, aggregate, which is the IDEA protocol. Now, this is a diagram that Victoria Hemming drew for her PhD thesis. She worked on this protocol. I've been using it ever since, so I can't not have her face on my slide. So that's pretty much what the IDEA protocol is. You get a group of diverse experts, have them to think independently, give those estimates in terms of an interval and a best estimate, anonymize and collate their answers in a feedback plot like that, and start your discussion, get your group of experts together, start your discussion based on those things and the reasoning behind it. It doesn't matter who says what, even though in most elicitations, everyone goes, oh, expert 3. It's not meant to say who you are if you don't want to. Some people don't. It's only meant, we're only meant to facilitate discussion around in what world this could be so uncertain or that uncertain, or these two don't overlap. So they clearly have a difference, this completely disjoint sort of mental model. Where does this come from? And so on and so forth. After they hear everything, they would go back, all the experts will go back and reassess. If they heard anything that changed their mind, they will change their estimates. If they didn't, they can leave the same estimates that they had initially. That's a very artificial example. Everyone changed their estimates. That almost never happens. So that we have now the dotted lines are the round 1 estimates, the solid lines are the second round estimates. And then at the end of that process, so the second round of estimates is the one that we mathematically aggregate. And you can have calibration seed questions or not. So you can do it with weights or just using an equal weighted aggregation. The reason we're doing this, well, there's lots of reasons we're doing these steps, but what we're trying to achieve is with the first individual independent assessment, try to avoid anchoring on other people's estimates and also use the anchoring. So then when you start the discussion, you are fairly invested, you're anchored on your own estimates. You spend a lot of time, you really believe those numbers are right. So you should hear something very convincing to make you shift your estimates one way or another. The discussions, like I said, has all sorts of benefits, but that availability bias that everyone has and maybe doesn't realize it, that will come to the table, and it's just like pieces of puzzle, brings everything together. And then because they have the chance of going and doing again the second estimate, but no one knows, you can change or not change your estimates, that should reduce, we're hoping, the groupthink and the dominating effect. I've seen PhD students agreeing with their supervisors in the discussion and not changing their estimates on the paper. It works, it's fine. So that's pretty much what we've been using in the University of Melbourne and in SEBRA for almost 10 years now. We've been collecting estimates and first rounds and second rounds in different applications, and it's always, for me, it's always absolutely fantastic because I learn the most I know these methods, I know the maths behind it, but I learn with every application a new domain. It's fabulous. But and about people. I learn about people. So my cognitive sort of knowledge and psychology comes from working with people rather than formal training. And I'll just go through how am I doing with time? Oh, that's great. Any questions?
Yeah, so yeah, if you wanted to move a bit more.
Sure. So I have a number of applications that I will just give you a flavor of. Unsurprisingly, two of them are biosecurity related, plant biosecurity, animal biosecurity, a little bit of the volcanology space, just because there's an impressive array of expert judgments that has been done in that area. And the Replicats project, we have a colleague here, so he will know everything about it. I've warned him that I may redirect questions to him if I get any curly ones. So in terms of the biosecurity application, we have lots of work with DAF. That happens often, but we also work with all sorts of institutes in the government from New Zealand. So we worked with the Cawthron Institute for a risk analysis when Bonemia Austria, which is something that affects oysters, came in New Zealand, and they really like their oysters, so they wanted to make sure they're healthy. We had a project with the Zespri and Ag Research, also from New Zealand, to optimize surveillance sort of strategies to keep the kiwi industry happy. That's either an LSD or an FMD, lumpy skin disease or foot and mouth disease for cattle. When it arrived in Indonesia, you probably would have noticed lots of things at the airport, lots of little mats that you had to clean your shoes on. When it came closer, the probability of getting an incursion in Australia was kind of worrying people. This is a project with the Biosecurity Tasmania. They were worried about pests and risks that are on mainland, but didn't make it yet to Tassie, and they want to see if they were to plan where to put resources, which one should they be more careful about. And that's one with the Department of Conservation in New Zealand, where they're looking at Stewart Island. They're trying to eradicate all pests on Stewart Island, on Racura, and they're worried about mice and rats. And after the eradication process, they want to know how sure can they be that the rats and mice won't reinvade on different pathways. Most of them involve pathway risk analysis and identifying spaces where you don't have the data and you go to experts. So there's lots of nice formulas that I sometimes have that I took out, so I don't offend anyone. But that's that in most of those formulas and models, you would have parameters that you get from your data and parameters that you estimate with experts. So for the Tasmania biosecurity plant pest, we looked at 5 of the pests that they were very worried about: the varroa mite, Q fly and med fly, potato tomato psyllid, and phylloxera. And they just wanted to see on which of these pathways, like from produce or passengers to air or sea, which ones are more risky and how effective their biosecurity measures are in terms of inspections and in terms of detected dog teams. And if they were to get an incursion and an establishment, what sort of impact would that have on the industry? How much will it cost them to eradicate or to contain an infestation? So we go to experts with lots and lots of questions. And there's a huge process before formulating the questions. We have to have the model, we have to have ethics application, consent forms, background documents, everything. So by the time we have the questions, we're almost finished pretty much. And the questions in their most simplest form would be an Excel spreadsheet, because everyone's happy to work with Excel spreadsheets. It's a nightmare for me to then take them and put them together, but they're happy, so that's great. So this is one of the, for this one, we had an establishment model, so the probability of something to happen, to go to get to Tassie and establish. And then we had the impact module, which again had some questions. This is for Q-fly establishment and spread. The question is the same and is repeated for different pathways: fresh produce, air passengers, and for different interventions. So this is just assume 1,000 independent entry events, how many of them will not be detected or eliminated using an intervention at the border? So this actually speaks to what's the effectiveness of the interventions that they're using on different pathways and with different interventions. And they have the fifth, the 95th, and the best. And then they have the comments that we all hope we'll get before we get to the feedback discussion round. So we can trigger them. And I'm always telling them exactly the same thing. Write down comments, not only for me as a facilitator to be able to trigger discussion on different points, but also for yourself, because very often they come to the elicitation and they go, I can't remember why I put those numbers there. So if they have the like just a few shorthand notes, that's usually great. And they do, they're very good. So that's about that one. And then there's the second part about the impact. So you see all the questions follow exactly the same structure, and they will all given instructions as much as we can. There'll be ambiguity. I've never formulated questions that didn't have ambiguities. So the second round starts with, this was the question that you answered. What did you think of when you did? How can you refine the question? So there's a refinement of the question happening at this before the second round. So in this particular one, like I said, lots of things happen before we actually have the questions formulated and the experts, but then the elicitation itself doesn't really take that long. So we have a remote inception meeting where we walk them through the steps of the elicitation and why we're doing things the way we do them. Practice question, usually, if we have any time, that would be their training in answering these questions in this quantitative way. And then they are given a 2-3 weeks since they get the questions until they have to actually submit all of these questions. And they all work independently, send me their answers. In this particular case, there were 135 non-unique questions, but you see they were grouped in those same question per pathway or per pest. And then after they submit, I put them together in feedback plots like this, I or whoever does the facilitation for the experiment, feedback plots like this, and we start the discussion in a workshop, preferably face-to-face, but we've done lots of remote. We started with a lot more remote elicitations during COVID, like everyone else. So then that works well, I think, but I think it's easier to have a lively discussion if you're face-to-face than remote, but it's definitely possible to have remote discussions as well. And it does help when you have international experts and you can't bring them in the same room. We go through each and every question and then they revise their estimates. So that's pretty much what a timeline looks like. And at the end of this particular process, what we looked at was, okay, so if you were to invest somewhere to increase your surveillance or to 10 more detected dogs to meet the spirit of Tasmania or whatever, which one would it be? And some of them, and we didn't kind of put them together. We did eventually, but as a first presentation of results, it would be, okay, so Madfly and Phylloxera will have a huge impact if they got there, but the probability of them getting there is so small that maybe it's not worth worrying about that next year, but put some things in place for the years to come. Varroa and Q-fly are much more likely to happen, and especially that one there, it's, again, human factors mostly, because they get smuggling. They smuggle in queen bees. And that's very hard to find with dogs or with inspections or with anything. So the probability of that to come is very hard to control for in the regulated pathways. So that's the sort of information that they would appreciate at the end of a process. This is a very different sort of time frame for what was this one? FMD, foot and mouth disease. So this was exactly when in 2022, when there was a little bit of, well, it came closer. It came to Indonesia, and the Australian government didn't necessarily like that and wanted to know if they need to act and what does that mean for the probability of an outbreak in Australia in the next 5 years. We had an elicitation done previously, like a year and a bit before, and they wanted to know how it changed relative to that. So we basically had one question, and we had base rate, as it were, to start from. So that happened in 2 days, pretty much. Very different than any other elicitation. But that can happen too. The classical model or Delft model applications, I think they may be the largest database that exists of collected expert judgments for uncertainty quantification in this space. And this is because Roger insisted that we should all collect all the data and have it stored somewhere from the perspective of doing cross-validations and verification exercises on anonymized data sets. And that worked really well in the Netherlands because I have not heard of an ethics application for an expert elicitation when I've done them in the Netherlands. That was something that, that I've learned about coming here. I am still not convinced we're not performing experiments on people, so I'm not sure what we're doing ethics. But because of the ethics application, we cannot keep the data for longer than 5 years, which means we can't do that. We can't do cross-validation exercises, and we can't learn from the data sets that we have with lots of the new data sets. But this is what we have from the Delft elicitation. So they're all with calibration, with seed questions. They're all with mathematical aggregation, performance-based, and they're all kept on different websites. There's been lots of cross-validation studies where we check what aggregation is better, what works, what doesn't. That's what I was mentioning with the Volcano application. Willie Aspinall has been running the classical model almost, I think, every other year, or with quite an intense frequency. Very often the same experts, lots of calibration questions because they need to take decisions about the eruption of the Montserrat volcano. So that happens over and over again. Is the longest running elicitation exercise done with seed questions that we have. I have time to talk about the Replicats project, or should I stop for more questions?
It's 7 minutes for questions if you want them, or talk about this. It's up to you.
Are there any questions up to now?
I have a question about the mathematical aggregation and the calibration.
Yep.
So the way you described it, the emphasis was on determining whether particular experts are calibrated, and they give you intervals that contain the true answer. I think it's possible to be informative without being calibrated, though. So if I'm really pessimistic about what you're asking me and I am consistently off by 50%, but it's always in the same direction, you could, in theory, use the answers that I give and apply some sort of adjustment. Is that something that you do, or is it just a matter of calibration?
We've talked about it quite a bit. So we're using both calibration and informativeness. We're not just using calibration. We do want the experts to first be calibrated and then informative, because if you indeed are very informative but always miss the realization, that's not that it's not useful. It could be very damaging to the final result. We could post hoc adjust the estimates, but we would assume that you would perform exactly this in the same way on the questions of interest, which is what we do anyway when we take the calibration questions. But that would be I think a fairly risky assumption to make. What you could do, what we thought we could do in this space is train your experts with that. Have a lot of calibration exercises and show them how they perform and what they usually do, and make them adjust after a while. And then go through a completely new exercise with calibration and questions of interest and do that. So try for the self-adjustment. We haven't done it yet.
Could you speak a bit more about the experts themselves? Because you didn't talk about it at all, the selection of them. So I guess that in fruit flies, it's very easy because you go, okay, who has a PhD on fruit flies? And that's a good beginning. But let's say the question, many of us are in the social sciences, let's say the question is amorphous, says what women want. So is Mel Gibson a candidate for the experts on this panel, or who's the expert?
That's a very good question. We don't know. So what happens is if the question is very crisp, like in the engineering applications, in the biosecurity ones, and it's not even, they don't have to have a PhD in fruit flies. They can be the inspectors. They can be, I think the first thing we go for is, do they all understand the question? Do they have knowledge about it? Are they interested in the subject? These are 3 things that we're looking for. Because the reason I said that it doesn't have to be a PhD is we couldn't find any prediction of how well they do based on the number of papers or PhDs or studies. So they have to have knowledge in the space, and it's easy for a very crisp, precise question. And like you point out, for a question that we can't define what's the expertise that you need to answer that question, then you just go for whatever proxies you have. Like in this particular case, this was about the replicability of science. We would give people papers to read and to see if a claim, if there is a replication, would it find the same effect in the same way? It was very hard to define what expertise was. So you just aim for diversity in the space. They would need a bit of statistics. They would need a bit of the social sciences. They would need a bit of psychology. Try and find the people who within a group cover all those aspects, and through the discussion inform one another and learn from one another. I don't know about the Mel Gibson thing. I will not answer that question. Sorry, I think.
Do you benchmark people before a session or semi-inform them about their idea of probabilities and what the rate of something is and so on? Because it seems to be asking, well, this is a 50th percentile, is 95th. Well, it's very hard to judge, like to separate it from the judgment of the incident rate of something and then the distribution of it is just so hard. So how do you deal with people maybe struggling with?
It comes out in their first round of estimates. So if we have time to train the people, we're going through a training exercise, and I think there's data about training being very useful. I haven't seen it yet, but I am told that there's going to be evidence on that. We always said training is useful because we teach our students and we know how they think in terms of probabilities, and then we observe that they can actually think probabilistically after you train them a little bit. So we try to train the experts, my students anyway. We try to train them if we can, and we always have practice questions. And within that exercise, you can identify who struggles, and you can identify what sort of language you use. So there are elicitations where I'm not mentioning the 5th percentile or the 95th percentile or the median. I'm just mentioning worst case scenario, best case scenario, best estimate, because the language is too complicated and they struggle with it. I think there were a couple more, and then thank you. I don't know who else was it. Yep. Here you go.
Just wondering, so if you ask about 50% versus 95%, and so you phrase it as think of all the reasons, right? Have you thought about making that part of it explicit, listing the reasons, or ranking them then subsequently? Or is that kind of something that comes out in the late discussion phase or in the comments? Like, I'm wondering if all the different reasons and how people can disagree on that, and kind of managing that and working memory, you can have it all comes together.
Yeah, also it's a bit of both things you said. We do have a background question, a background document that always goes out with the questions. And for each of the question, you will have everything that is known, the situation in other countries, or the situation in a different year, or whatever it is that you can approximate. So it's like the known knowledge about this particular subject. Within those, you would have reasons that would make you think that number will increase or decrease. So they have that to start with. And also we're anchoring everyone on that. That's the research that we start. That's the base rate. That's what we start with. And so that's one. And another one is we do ask them to write down what were the reasons in those comments. What did they think of for the reasons for these numbers to be low or high? And that's exactly what we tend to discuss during the discussion stage. And that those reasons sometimes people disagree with, sometimes they go, oh, I didn't think of that. And they just include it in their bounds. So that's, yeah. I don't know how well it works.
So we've probably got time for maybe one more question if it's quick.
Yeah. So do you ever, maybe at the end of these kinds of processes, or just separately to analyze your effectiveness, just compare the outcomes you get to asking the experts about the outcome question rather than sort of the model assumption kinds of questions. Because like there's this idea in the sort of like wisdom of crowds kind of space where you have this idea that people's errors are random in ways that often sort of balance out in ways that lead you roughly to the correct answer. You know, in the same way that lots of the individual estimates that experts make might be wrong enough that when you stick them into a model, the outcome can be biased. Is it possible that just asking about the outcome is roughly equivalent? Is it much better, much worse? Does it, yeah.
I think it depends on how complicated those models that you stick in the inputs. So we ask about the inputs all the time. I never ask about the outputs. There are people who do that. There's like within the European Food Safety Authority, there's places where they don't have the time to actually build a model. They don't have enough information for that, and they just ask about the outputs. So it is possible to do it, not necessarily to compare it, like they don't do it both ways and see. We very rarely have time or resources for such cool experiments, because it's usually we do it because we need to find the answer. But I guess one of the reasons not to ask for the outputs is they're easier to manipulate. If there's any motivational bias that goes up within all these questions, because we try to separate, like I said in the beginning, we try to separate facts from values, but you very rarely can completely divorce them and just have them. So if there's any sort of motivational biases and manipulation of results, it would be very easy to do it on the output and a lot harder to do it in the inputs because they don't know what we do have though is sometimes in those establishment models, we break the problem down in probability of entry, probability of establishment given entry, probability. So it's a formula that gets to the, we have a formula that shows them. So with all the numbers that you gave us, you think this is the probability of the next year incursion. And they sometimes look at that and go, oh, this is ridiculous. So they go back and look at what sort of, which one of the components they overestimated or underestimated. But that's more of a cross-checking and internal validation than external one.
All right, with that, can we please thank our speakers?